Hi, welcome back, guys. So let's get started with the exercises. We have studied about processes, and let's try to implement processes. As was discussed during the lecture, that fork is the command that is used for creating processes in Linux, and we are going to use Linux to do that. So we are going to use fork. So I have included, as always, some exercises at the end of the lecture. So this is the first exercise that was included with the PDF for this theoretical part. So it says that create a program in C that prints a hello every time a process is created using a fork call. So this is what we're gonna do. Let's start doing that first of all, and let's see how it works. So what I'm gonna do is I'm gonna write a C program. So let me save this as okay. So let me save it as hello underscore fork. So this is our first a fork program. So I'm gonna create a C program. So in order to make our program work, we need to include necessary libraries for displaying the output in C. We normally use stdio library, just like in C++ you use IOStream. So for C language we need to include stdio that helps us in printing things on the console. This is a very standard library we use, and the other library we use over here is important for fork. So a fork command is available in under this library, unistd.h. So our fork command is inside this library. If you don't include this library, our fork command will not work. Then I'm going to create a simple main method, and I'm going to return 0 first. So and let me print first of all nothing but just to print hello, just to show you that this is how the program looks like. And let me do a new line over here as well. Let me print this, and since most of you have not worked in C, it's pretty simple, but maybe you have not worked in Linux also, in C++ as well. So I'm going to write a very simple command to compile it. I did this last time also, but I'm going to do it for you this time as well. It's going to be a little bit different. It's going to be simpler this time, because last time we were running kernel module, so we had to make our make file, but this time we don't have to use a make file. We'll use a built-in compiler. So I'm gonna just compile this file. So in order to compile this file, I have to go to my specific folder first. Inside this specific folder, so I have this file over here in this folder. I'm going to compile it. So for compiling C, we use GCC. That's a built-in compiler in Linux. So this is the command, and the file name of the file I want to compile, which is hellofork.c in my case. Then I will do -o to put the output name of the file. If you don't want to put the output name of the file, you can no need to put that -o and the file name. It will generate a.out for you. It's totally up to you. For me, it's always a good idea to know which files I'm generating. So this is how you compile a file. If I press enter over here, so just to quickly tell you what it means, GCC is the compiler name. This is the command that we're going to use, and this is the name of the file that we're going to compile, which was what we created. This is the file. -o means what would you want to put the name of the output file. I said it should be the same name, hellofork.o for output. That's it. And in order to run this program, to execute this program output file, I'm going to do /name of the output file, which was hellofork.o, which was generated by GCC for me. So if I press this, it just prints hello, nothing else. This is exactly what I was expecting. Very simple, nothing fancy. So what we're gonna do is we're gonna write a fork command now. So let me write fork. So I want to create two processes from my program. I want to create a process, for example. Let's start with one process. I want to create a program. So this program will generate for me a process, right? And whenever I'm using a fork command, if you remember in the slides we discussed as well, so whenever we're using fork command, what it will do is it will create two streams for me, one for the parent and one for the child. right? So two streams. So it will create a parent stream as well, and then it will create a child stream. So this is what I'm going to do. I'm going to call fork command, that is just like that, and print semicolon. If I execute this, so I'm going to compile it again, I'm going to execute it again, nothing fancy, nothing has happened, because we have just created fork and we have not seen the processes, we are just seeing the output, and processes are not displayed in the output. Now let's see how fork has worked over here. What I'm gonna do is I'm gonna print this command. Let me just remove this command first of all, just to give you a better idea of what will happen. So I will remove hello world as expected. Nothing should be printed outside on my console, so nothing is printed. Very easy. Now whatever I want to do is I want to copy this hello command after fork. So fork is there, it's going to create a parent stream for me and a child stream for me, and I'm going to print hello. Let's see what happens now. Let me save this, let me clear this out, compile this and execute this. If you see, it printed hello twice, right? It printed hello twice, but I have written hello only once. What's going on? Something wrong with the compiler, right? Nothing wrong with the compiler. This is exactly what fork does. So what happened over here is, let me go and explain it to you what happened over here. So what happened over here is, I had a process, so my program was running in one process, any process, maybe it's P1 for example. This whole program was running in P1 process, and as soon as it saw fork command, as soon as my program saw fork command, what it did is, so this is for example my program P1, let's call it P1. As soon as it saw the fork command, let me write it for you over here as well. So it saw a fork command over here. What it did is, as soon as it saw fork command, it split it into two streams. So it split it into this one and it split it into this one. So it split it into parent, which was the same process, let's call it same process P1, and then C1, and it created a child as well. Why? If you see over here, this is exactly what is happening. If I call a fork command, it will create two streams for me, the parent stream for me and the child stream for me. This is exactly what is going to happen over here. So as soon as fork command is executed over here, it will create a parent stream for me, and then it will generate a child stream for me as well, right? So this is what is happening, and since there are two streams over here, my hello command is executed twice. So there was one hello for parent and the other hello for child. This is exactly what is happening if you see over here, right? Fine, this is, I hope this is clear. So whenever fork is called, two different streams are created for me. So if I'm calling hello after fork, so this is exactly what I did. I was calling hello after fork. So I printed hello after fork. So one hello was for parent and one hello was for child. Right, this is exactly what is happening. All right, so this is this. Now what we're going to do is, let's call fork again. So let's call fork again and let's print the message again. We have two fork calls and we have two or let's not print it for now, and let's see what happens. So let's compile. Oops, semicolon missing. Save again. Let's run it. If you see, nothing happens. It's the same print because it's printing this one twice. Now what I'm going to do is I'm going to print again. So I have two fork commands and I have two print commands. Let's save this and run this and see what happens now. So if I compile it and run it, you will see that it says 1 2 3 4 5 and 6. It's printing 6 times. It's printing this for me 6 times. Let's see what's going on. So what I did, this is clear, that first time I called fork, I had a hello command. One hello was printed for the parent and one hello was printed for the child. That's clear. Now I called fork once again. So I have called fork once again here. After printing hello, I have called fork once again. So what will happen now is, fork will again create two streams for parent and child. So it will create two streams for this parent like this. Keep it maybe here like this, and it has created two streams for the child as well. So this is what is happening now. So what it did is it created one stream for the parent here for the parent. So this parent is coming directly here. This stream is for parent, parent remained same, parent remained same. And it created another child from this parent like this. It created another child from this parent, and for this child it created, let me just rename them so that you better understand what's going on. And from this child, since I called fork again, this child now becomes parent and it creates two more streams for it. So this stream remained for C1 for the same parent, which was the child also. So it will remain child, and another one for creating another child, maybe called C3. This one is P1. Let's call this one C2. So this is what it did. So first time when I called fork, it split this one parent into two streams. One parent stream, it will remain the same. Name of this will remain same. If I have parent ID, if I see the parent ID of this one, process ID for this one, it will be same for this one. However, process ID for this one will be different. I'll just show you in a while. And two of them were created for me, and hello was printed twice. If I see now, so I'll have a hello here also for this one, for this one, for this one, for this one, right? So I already had two hellos printed before when there was one command. So these two will be printed as it is. But then when I called fork again, what it did is it took this one, it took this process and created two streams from it. So one stream was the same parent stream. It will have the same parent ID like process ID like this one, like this one. It will have the same process ID, which is this stream. It will continue like this. And from here it created another child, which is C2. It will have a new process ID now. And at the same time, it saw that it has another stream going on, and it has to run fork on that as well, right? So what it did is it created the same stream for the child. From here it will continue for this child. It's a parent now. It's a child as well, it's a parent as well, so it remained over here. So whatever is the process ID for this one, it will remain process ID for this one as well. And then it created a new child C3 with a new process ID for this, and it will print, since we have printed hello again after this, it will print hello for all these four as well. So 4 hellos for this and 2 hellos for this. This is exactly what it's showing. It's giving us 1 2 3 4 5 and 6 hellos, right? It's printing 6 hellos for us. This is exactly what we expected. Now let's do this once again to further understand what's going on. Let me print fork again, and let me print hello again. What do you think, how many times the hello message will be printed? Let's see what's going on. So let me clear this up. Let me compile this and run this, and you will see. Let's count how many times. 1 2 3 4 5 6 7 8 9 10 11 12 13 14. So it printed 14 times, right? It printed 14 times. Let's see how. Maybe let me move this a little bit up to draw more child over here. So what I'm going to do is, so I have called another fork here, and what happens now is, oops, and what happened now is it actually created something like this. So it created two children for this. It created two children for this. It's gonna be difficult for me. Let me reduce their sizes. Okay, something like this. P1, something like this. P something. Let's call it P1. Okay. Okay. So I have created something like this. So this is for this one, and same thing for this one. Bring them down a bit. Move it a little bit up. Okay. So for this one as well, and for this one as well. So what's going on now is, so when I called fork here, what it did is it will create two streams for each one of them, right? So what it's going to do is it will create a stream for a parent just like that, like that. So another child for this parent. Then it will create, it will keep the same it will keep the same stream for this C2. I'll name it in a while and then you'll get to know. And another child for this. Similarly for this one, it did exactly that for all of those children. And this, so let me name this. So P1 parent stream will remain like this. Let's call it C4. We don't have C4, let's call it C4. Then this stream will remain like this for C2. So one of them is a child, is a parent, so C2, it will remain the same like this one, and it created a new child. Let's call this C5. For this one of them remained the same, C3, and it created a child. Let's call it C6. For this one it remained maybe C1. Since it's on the right hand side, I'll keep it that convention. And then it created C6, sorry, C7. So it had these children now. So it will have hello for this, for all of them. So it will have hello message for all of them. So if we count now, so 1 2 3 4 5 6 7 8 9 10 11 12 13 14. I think this is exactly what our message printed. 1 2 3 4 5 6 7 8 9 10 11 12 13 14. So this is exactly what our program printed, and this is exactly what we were expecting. It will keep on becoming like this. So if I call folk once again and then call hello again, this parent or this node will have two more children. I mean one children and one copy of itself. Same with this one, it will have one copy of itself and another child, and so on for all of them. So this is exactly how folk works. And in order to see, for example, what I'm gonna do is I want to print the ID for all of them. So anyways, let me finish this and then I will create the ID for each of the process and see how IDs are different. So this is how it works. So every time we call folk, our main program is divided into two children. I mean two branches. One of them will remain a parent branch, another one will become a child branch. If we call it again, then it will further subdivide it. If you call it again, it will keep on subdividing it. So this is how your folk command works. It's very important that you understand how it works, because sometimes it becomes very confusing. I try to make sure that you understand through a tree. That's why I included a tree inside the theoretical part as well. And this is how folk works over here. So this is it for this exercise. So what I'm gonna do is I'm gonna move, let me see what other requirements we have in the exercise. So exercise number 1, okay, so we did this, we printed hello every time. Analyze the program to see the output changes with the increase. So we saw this, that it increases with the increase in number of folk calls. Demonstrate your understanding how many processes. We have seen this. Use get PID method to get the, okay, so this is the next step. So we want to get the ID of each process, right? So get the ID of each process. I'm going to get rid of few of them, and let's start with very simple one. So I want to get the ID. Now IDs of the processes are assigned by the operating system, so we don't know what the IDs are unless and until we call a method that gives us the ID. So in order to get the ID of the process, so in this case, since I have only one folk called over here, so it will have a parent and it will have a child. So since I have removed all of them, so what we're gonna do over here is I'm gonna say process ID is, so in C language, if I want to display a variable and that is a decimal data type, or I mean any numeric data type, then I use -d. So -d, what it will do is it will, and I will put specify what I'm actually looking for. So let me just first call and then I will explain this. So get ID, and this is a method. Get ID is a method available in this library. What this will do is it will give me the ID of the processor. Let's see what's going on over here. Let's compile it again and see what we have. So process ID, you see that process ID is this one and this one. Why it's displaying two? One because we use fork, so one of the process ID is for the parent, and the other one is for the child. So this is what we expected, right? If you call multiple forks, if you make multiple fork calls and try to display this, try to use this, then it will display the parent ID for all of the processes. It will keep on displaying those. Now let me quickly explain what this is doing for people who are not aware of C language, but I'm not going to spend too much time on this. So printf is going to print something on the console. This is a string I want to print, and %d means any decimal point that I want to put, and that decimal point I will put after the comma. So any decimal point, this decimal d will be replaced by any value I have over here after the comma. So if I have two values over here, for example, if I have two values over here, I have to specify two values over here, like this, right? So since I have only one value, I will keep it very simple like this. So any value you put, and it's again a keyword over here, it will be replaced by any integer value over here, any decimal value over here. Normally you can convert, if it's a float value, you can convert it into integer just like any other programming languages, we can do that. So you can do that as well. So this is a very simple program that will give you the process IDs of all the processes that are being created by your program. So it's very simple, nothing much difficult in that, just two simple calls from the library. One is for the fork and one is for get PID. So very simple. So this is it for this program. Now I'm gonna create a new program and gonna see that how I can distinguish between or let me change this program, how I can distinguish between a parent and a child. So if you see from here, if I go to the output, I have two IDs. Now I don't know which one is a parent ID and which one is a child ID, but I can say that this is a parent ID because it has been created before 4003, but not necessarily. I mean, operating system can randomly give numbers to the processor and we cannot guess. So it's always a good idea to know through your program who is parent and who is child, right? So when I called a fork method over here, what fork does is it returns a number. Right? So let me say int I, and let me take this value of I into value fork into I, right? And let me try to display this value of I and see what's going on. So let me see, compile and run. You will see that process ID is 412 and then it says 0, right? So what it's actually doing is it's giving me the process ID, but it's returning 0 to me also, right? It's returning to me 0 over here. Now what fork does actually is it will return you three of the values, any three values, and those three values will be, if fork is returning you, let me write it over here, if fork returns 0, it means that this is a child, right? If fork returns anything less than 0, anything in minus, it means there is an error creating a process. There was an error creating a process. If fork generates something greater than 0, which is normally the ID of the parent, then it means that is parent. Very simple. So it will be parent if it is greater than 0. So this is what was happening over here. What happened is, first time, since it has to return two things because I use fork, so first time it returned 412. 412 is greater than 0. Yes, it means that this is the ID of the parent. So I got to know that this is the ID of the parent. And next time it returned to me 0. Since it returned to me 0, it means that this is child, right? So I can distinguish from here which one is parent and which one is child. So for example, from here, if I want to see what is the ID of a child and what is the ID of the parent, right? So what I'm gonna do is I can do something. I can use an if statement. So if I is equal to 0, since I said that if fork is returning 0, then it's a child, then it's very simple. Let me use this print statement over here, and I will say that I am a child and my process ID is and my process ID would be, how to get a process ID is to use get PID, right? I can use get PID to get the process ID. Very simple. This is what we did in the previous exercise, right? So this is one thing, right? So if it's equal to 1, if fork is returning if it is returning 0, then it means this is my child. This is what I said, that these are one of the flags. If not, I can test all of them, else if I is less than 0, then error, but I'm not going there. So what I'm gonna do is I will just use else. I'm not checking an error, but it's always a good idea to check an error. So you can have else if I is less than 0, then error, or you can say else if I is greater than 0, then I am parent. So this is what I'm gonna do. I'm not gonna check an error. So anything else, anything which is not 0 is going to be a parent. This is what I'm assuming, but it's always a good idea to use another else if statement. So I am a parent and my process ID is get PID. This is exactly what I want. So that's it. If I run now, let's see what happens. So like this, and let's compile this. So you can see that I am a parent and my process ID is 421. So it ran this one first, and then I am a child and my process ID is 4211, right? That's pretty simple. So I'm just using get PID because I know get PID is going to return me the process ID, right? It is going to return me the process ID, and I know that fork is returning me something, either 0, less than 0, or greater than 0. So if it is 0, it's a child, right? So I can easily distinguish between parent and child now by using very simple code like this. Nothing so special, just use of two main functions from this library, a fork function and a get PID function. It's very simple. There is nothing special in that. So I hope it is clear. It's not very difficult at all. It's pretty simple to find out who is parent and who is a child, and we can use simple if else statement to do that. Okay, so this was this. Let's see what we have in our exercises. So that's what we said, that how to use get PID method to get the IDs of the processes. It's very simple. So this is what we did. Let's move to exercise number 2 and see what it says. It says create a program in C that prints all the odd numbers from 0 to 20 in a child thread, child process, it should be child process, and all even numbers from 0 to 20 in the parent process. Alright. So okay, so we need to create a C++ program that generates all the odd numbers between 0 to 20 in the child process and even numbers from 0 to 20 in the parent process. Fine. So the program should distinguish between parent and child process along with the corresponding outputs. We know how to do this. Make sure to print the process IDs of both the parent, and we know how to do this. So I think the first one is the one we are going to take some time on developing, and it should not be a problem. We know how to generate odd numbers, we know how to generate even numbers, and it's all about calling them inside the right if statements. So let's create separate functions. So let's create a function, maybe void show underscore odd, and normally it's a good practice to put void inside it in C if you don't have any parameters. So I want to generate odd numbers between 0 to 20. So what I'm going to do is int I is equal to 0. It's a very simple code, less than 20 I plus plus. So I'm not going to explain this code because I believe this is very simple. This is one of the first codes we write when we are using loops and if statements, generating if and else, generating even and odd numbers. So I mod 2 is not equal to 0, then we're gonna printf, let's call it, I'm gonna tag it with C because it's a child, right? So we want to call it in child, if I'm not wrong. Odd numbers in child, yeah, just to tag it with child so that we know that we can know from the odd numbers as well. But let's see. So let's do this and D, and we want to display I, right? This is how we do it. This is how we do it in C. So it will display me, this will be replaced by the value of I, right? And I is going to be odd number. So I'm going to copy this and I'm going to generate a method for even number also. Let me full screen this. So let me call it show even, and this is this, and this is very simple equal, and let me call it parent, and yeah, that's pretty much it. So I've created two methods, very simple. One will generate for me odd numbers and one will generate for me even numbers, and I'm just gonna call them. So I will use this program to change something here. So yes, it's all about calling the methods, created functions inside appropriate if statements. So odd number is uh, in the child, so show odd, that's it, and show even would go here, show even would go here. That's pretty much it, I guess. Let's see what's going on. Let's compile. Yeah, so it says I am a parent process, my ID is this, and these are even numbers from 0 to 20. That's very good. I am a child and my process ID, this is the process ID of the child, and these are the odd numbers. Perfect. Very simple. It took us around 2 minutes to do this. Very simple. Nothing so special, but just to give you an idea that how you can do different things in child and parent and child, right? So this will work in, since you are in this statement, it means that you are working on the child process, so you will work over here. Then you are in the parent. I mean, obviously you can clean this up by using the error if else if also, but over here you are in parent, so you generated some numbers inside the parent process. So very simple. Try to do different things with it. Try to see if you can do some variations with this. There are so many things you can do with this. If you have used Java, maybe you have used threads in Java as well already. So try to use some of the exercises of that inside the processes and see if you get a better understanding of what's going on. I think it's very simple. It shouldn't be a problem. No complicated code over here, very simple code over here. It should make sense. If it's not making sense, obviously you can ask questions. Please ask as many questions as possible and try to do different variations of it. Yeah, this is my advice. And exercise number 3. Yeah, I really wanted you guys to do this exercise, but since this is the beginning of the course, I will do this exercise for you, and because there are maybe some new things in this exercise which you might get confused with, but I really wanted you guys to experience doing some research also. Just go here and there and search for things, how to use these commands. For example, this exist cvp command, what are the parameters inside, and I've actually written over here how to find information on this. You can Google it as well, but let me do this exercise for you, although this is a practice exercise for you, but let me do it for you. So what we want to do over here is we want to create a program in C that takes 2 Linux commands as a parameter. So okay, so it takes two commands as a parameter. ls is for list, we know this is a command, and cal is for calendar, so you can use any command, I guess. These commands should then be run in different processes. For example, ls runs in child process, okay, cal runs in the parent process, okay, we know this. I think we can do this. You can use this command for running Linux commands in C program, okay, and we can get more help from this man in the terminal. So okay, so what we want to do is we want to take two Linux commands, two legitimate Linux commands from the parameter as a parameter, and then we want to pass these commands, one in the child process and one in the parent process, and then show the output. And in order to run the command, it's written that we can use this. Okay, all right, so yeah, this program contains few things that I need to explain. So let me get rid of this program first of all, and let's see how we can approach this. Okay, So first of all, what we're gonna do is we want to take two outputs, two inputs as parameter. So since we want to take two inputs as a parameter, you can either take these inputs from the user or you can take it as command line arguments. So you know how to take it from the user. Scanf is what you can use. I'll leave it to you. But I'm going to do the difficult part for you. So I'm going to take two commands from the command line, and then I'm going to run them. Okay. So when I want to take some commands from the command line, I have to change my main method. So in order to get some commands from the main method, I have to then specify some parameters here. So I'll specify a variable, integer variable args, and I need to specify character variables, and it is going to be a pointer. This is traditional way of writing a main method. Normally main methods in C++ and C are written like this, but just to avoid some complexities, we normally don't write parameters inside, but this is the right way to write your main program. So what these parameters are, quickly want to explain you that this is the length of the parameters that I'm gonna provide, and these are the parameters I'm gonna provide. I'll just show you what's going on and you'll get a better understanding of what is happening over here. So what I want to do is I want to print, first of all I will get some parameters. So let me show you what I want to do. So let me clear this. What I want to do is, let me compile this like this. Oh, what happened? Int main. Oh, let's see. Oops. Alright, so what I did over here is I used the same name. I cannot use the same name. So args and args are same name. I cannot use that. So let me change it to v. Let's do that. Okay, let's run again. So it compiled. What I want to do now is I want to take some parameters from the command line. So this is how I execute my code, and I want to specify over here my commands. So I want to take arguments from here, command line arguments. These are called command line arguments. So I want to take two commands from here. So one is the ls command and one is the cal command. So I want to take these arguments from the command line. But you can take it from the user as well. So you try it yourself by taking cin, as we call it in C++. You can use scanf in C language to get input from the user, and then work on that. But I'm gonna take like this, so it will be some learning for you as well. So as soon as I get these commands, what I want to do is I just want to start with, just want to display these commands. So I want to make sure I got these commands inside my program. So okay, so over here what I'm gonna do, I'm gonna print f whatever commands I'm getting from there. I'm gonna just print them and see how they are working. So let me call it first command, and I'm gonna call it, and my commands, whatever I'm entering, it will be in this array. It will be in this array. This is just the length of my commands I'm entering, right? Length of the words I'm entering in my command. So these are the actual words I'm entering, right? So this is an array. So in order to get something from the array, I have to specify the index. Let's see. Basically, the first argument is the name of the file, but I'm going to show you how we do it so that you actually understand that what's going on. So let's do this arg of 0, so array of 0. So since it is going to be an array, whatever I am entering, each command will be available in this array. So what will be at index index 0? So let's run this command and see what will be on index 0. So if I run this and I specify the same thing, so when I'm running my command, I am adding some extra parameters, the commands ls and cal. And when I enter this, you will see that the first command it says is this one, the name of my file, and this is exactly what it is. This whole thing is my argv. This whole thing is my character array, contains all of these elements. So at first index I have this, at second index, or let's call it index 0, at index 0 I have this, at index 1 I have this, at index 2 I have this. So since I printed over here array of 0, so array of 0 is this part. That's why it's displaying me this part. If I change this to 1, save it, run it again, compile and run it again, you will see I will get ls, right? My first command ls, and similarly I can get cal too, cal, right? So this is how you get command line arguments from the command line, if you want to get it from the command line instead of just getting it from the user scanf. And this is how you can manipulate them, right? So what I'm gonna do is I'm gonna see how it works, since it says use this command with the parameters to run any of the Linux commands. So first step would be, I'm not going into parent and child processes. What I'm going to do is, first of all, I'm trying to run that thing, right, and see how it works. So what happens is, I'm going to do it first for you and will show you what can go wrong, and then I'm going to fix it. So I'm going to use this command, which was written in our PDF file as well for your exercise. So it says that you can use this command, specify the parameters. Well, in order to get some more information about that, we can use this man execvp, and it will provide you all the information about the parameters and everything, and you can see over here what it requires, what are the details. So I'm not going to go there, so since I know this. So what I'm going to do is execvp, and inside this I have to provide the command, right? So I have to provide the command. I tried to provide some information over here. Yeah, so it says character command. So this will be the first parameter will be the command, and which is our command for ls or cal, whatever we specify in our array through the arguments. So what I'm going to do is, I will do arg v of, I will not do 0 because 0 is the name of the file. I will do 1, and the second argument, it says it's the parameter, right? It's the parameters, right? So if you see, since I'm going to provide ls as a command, so and I told you in the first exercise as well, all of these commands, ls, copy, move, all of these commands are basically programs. These are programs, right? And they accept arguments. If I do ls, it's a program that will list everything in that particular folder. So right now I have only 2 files in this folder, and these commands also take arguments. So what arguments these commands take? Well, every command takes different argument. ls takes -la argument, and if I do something like this, if I provide this argument, it will show me a lot of detail about these 2 files, list and list -la. It will show, or for list it will show -la, means it will show all the hidden files, if any. It will show security permissions. It will show all the details about that. So it takes this argument. So this is exactly what it says over here. So first parameter of this command is the actual command, which in our case was ls. This is the command, which is ls. The first argument is ls, and second argument is -la, right? -la. Now if you see, it's not a character like character command here. It's an array of characters. So it takes array of arguments, right? It takes array of parameters. Now we don't have to provide array of, what I want to do is, I don't want to provide -la, right? I don't want that. I want simply ls. Whenever my program runs, it will just display me ls. I don't want -la. So I don't want to provide any other parameters over here. I simply want to give my command, and that's it. So let's see what we do and what can go wrong. So if I provide this, so this is my array, right? This is my array, and it says you have to provide array. So as per the requirement, I'm doing everything right. So the second parameter accepts the character array, right? The character array, and this is the character array which I'm providing over here. Let's see what can go wrong. So clear, let me compile this. Okay, this is uncommen. Okay, so let's run again, and let's see where we had those commands. Yeah, so if you see, it will start saying that cannot access LA, no file or directory available, right? No such file or directory. And it's saying same for the cal. It means that my program is getting these parameters, which is excellent. It's getting those parameters, but it cannot find it. It cannot find it. Why it could not find it? Because it needs an array in a specific order. It needs an array in a specific order. So what is that specific order? It has to end with null. It has to end with null. So what I'm gonna do over here, I'm gonna create a separate character array and play with that instead of just playing with these and then messing up with them. I'm gonna create my own character array. So I'm gonna call it my array, my character array, right? And let's call it size maybe 10. We know how to create an array, right? This is how we create an array. This is how we create a character array. In C++ it's similar, right? And in this one, what I want to do is my first element of this array would be my my command. So what I'm going to do is my array of 0. So first element of my array will be this command. And where is this? ls, right? ls, which was this one, right? So what I'm going to do is, and where is my this value? This value is available here. I can access this value from here, right? So I will do this. I will do something like this. So what is happening now is this contains ls, and I'm going to save my ls into my array's 0th location, right? If you don't want to do it with a separate array, it's absolutely fine. If you understand how to manipulate this and you want to do it this way, it's absolutely fine. I'm just trying to do it in a cleaner way so that you guys understand what's going on. And the second argument requires a special set in a special format that is ending with a null. So what I'm going to do is I'm going to say my array. So since I'm not planning to specify any arguments here, which you remember from ls dash la, I don't want to provide dash la a parameter. I just want to provide ls. So what I'm going to do is the second argument or argument at or element at first index of my array, I will make it null, because I don't want to provide any more parameters to this array, right? I don't want to do that. So, and that's it. What I'm going to do is now I will replace this with my array, but this is going to be 0 now, right? Because I have placed it in my 0th location. My arg1 is now at 0th location. And now the element, this array should, this command requires us that the second array argument is a character array that ends with a null. So this is what we have done. So we have created a new array and we have ended that with null, right? We have used only the first two arguments, although the size was 10. We don't want to use all 10 elements. We're just using first two elements, and I'm going to replace this with my array. And let's see what's going on. I'll do something like this. And let's see what happens. So let's compile, let's provide this, and this is exactly what we were looking for. So my command ran properly. It just went into my folder and showed me the list of elements, right? I could have done something like this. I can do something like this. I can do this one. I can maybe put over here dash LA, and I'm gonna do 2 to this, save, run, semicolon missing. Okay, so I'm doing like this, and you can see that I can provide the parameters also. So now I provided dash LA parameter, and within that folder it provided me all the information about the files available in that folder. So I was able to run Linux commands from my own C program. How amazing is that, right? How beautiful is that? So you can run Linux commands, that much power you have with C language in Linux. So that's why I wanted you to use C language, because not many other programming languages have that much power. So you can control Linux from within your C program. So this is how you do it. So you are running C language, you are running Linux commands from within your C program, right? So this is how you can do it. So this is one of the parts of the program. So this is what we did. So the second part of this program is that we have to run these two commands from parent and child processes, and this is exactly what we're gonna do. So in fact, I will leave this to you guys. I have done the difficult part for you. So rest of the things are very simple. What you have to do is you just have to use a fork statement, then go to run an if statement, control statement, to see if it's a child or a parent. If it's a child, then run this one. I think this is what it says. Run ls. I mean, this is just an example, so you can change anything you like. This command can be date, this command can be calendar, this can be anything else you want. So inside this, inside the if statement, you have to check if it's a child or a parent. If it's a child, then you can run one of the commands. If it's a parent, you can run the other command. And I've already told you how to run Linux commands, and this is exactly how you can run the Linux commands. So that's pretty much it for this lecture. I have explained you the exercises as well. In fact, I have performed this practice exercise for you as well. You should have done it yourself, but I have done this for you. I hope fork commands are now clear. I hope you know how to call parent and child processes, how to distinguish between them, and I hope that you are able to run Linux commands from your C program using this command. And I've just left this last part for you to call this in a parent and a child process, and that's pretty much it. I hope this is clear. If you think that something is confusing, if you still don't understand anything, please drop me an email and we'll arrange a time for you. Otherwise, you can join me in my virtual office hours and we can discuss over there. I hope it is clear. That's it from my side. Thank you very much. Bye bye.